Hello everyone, this video is meant for a quick revisit to our topic pulse code modulation. So why is pulse code modulation needed? As you know, for conversion of analog signal to digital signal. Now we have an analog signal, suppose it's a voice signal or it's a video signal. So whatever analog signal is there, it has to be converted into digital. For digital transmission, it has to be converted into digital signals, and we achieve that using pulse code modulation. Now analog signals are any signals that is continuous and that is found in nature. So any signal that is analog signal and that has to be converted into digital signal, and this is for transmitter. For transmitter, analog signal has to be considered and converted into digital signal. For receiver, the opposite will happen. For receiver, the digital signal will be converted back to analog signal, and that's what we do in PCM. In PCM, we convert in PCM, in transmitter we convert the analog to digital, and then we pass it through a PCM channel, and then we convert it back to analog in the receiver. Right. Now let's go through the PCM transmitter first. A PCM transmitter converts an analog signal into a digital signal, and it has three key components, and those three are sampling, quantization, and encoding. Now sampling. What is sampling? See, what happens is that, suppose this is your signal, continuous signal. So in this continuous signal, what we will do is we will read the signal after a certain interval. So we will take certain samples after a gap of certain points, because an analog signal is continuous and it has infinite number of points between any two period. Between any time period, it has infinite number of points, and we cannot send infinite number of points, so we need to sample it. So what we will do is we will sample it here, then in the next point, and then in the next point we will record the amplitude after a second, and this process is called sampling. And the result that we get from this is discrete time signal, which is discrete in time and continuous in amplitude. Okay, so this is a necessary part before conversion into digital bits. Now second thing that we need to do is we need to quantize. So what is quantization? Quantization is approximating to nearest value. Now your samples may be of any value of amplitude, but we cannot have just any value for transmission. We need to approximate them to some fixed values. So we will have certain number of levels, and we will take each sample and set its nearest level for that. So this sample will be quantized to this level because this sample is nearest to this level. So we will have our quantized value of that signal into this, where we will have 4 values, and you can see every amplitude is of every sample is of the amplitude of one of these 4 values. Means it was earlier not among these 4 values, but we have quantized them, and they are now, every one of them can be represented by one of these levels. Okay, so now why do we do that? So that we can encode. See, encoding is giving a code for each amplitude level. So let's consider a -4 volt to 4 volt amplitude. Now what we will do is we will take these 4 levels, these 4 possible levels, and we will give a code to each one of them. So for 4 we have given 1 1 and comes down to -4 is represented by 0 0. So we will transmit 0 0 for -4, 0 1 for -2, 1 0 for 2, and 1 1 for 4. So likewise. Now what happens is that we take it in the order of 2 to the power n, where n is the number of bits that represents each level. So it gives 2 to the power n number of quantized levels. Okay, so now let's get back to our PCM transmitter. So how does it work actually? So for this to work, what has to be done first is that we will have to have an input, and so we will have see, at this input we will give a continuous signal, and what happens after that is that this has to be converted, sampled and converted into discrete time signal. So in goes this signal and out comes this discrete time signal, and this discrete time signal is then fed to this quantizer because it needs to be quantized. We need a definite number of levels. So this is converted into this quantized levels, where we have converted in each sample into its nearest level, and we have represented it into its 4 levels. So from now here we need to encode them. Now let's take the first sample and we will try to encode it. So what does it represent? What bit represents this level? 1 0. So we will have a 1 0 transmitted for the first sample. So we will have an 1 0 transmitted for the first level. This is how things work. Now going into the detail of the functionality, what has to be done is that for sampling we need a sampler, and for quantization we need a Q level quantizer, and for the final level we will need a binary encoding. Has to be done with an encoder, and as you know, an encoder has parallel outputs, and for that we need a parallel to serial converter so that we can convert it. So I'd recommend you refer the book for their proper diagram, but to understand the working I have explained you in this way. All of them will be connected to a synchronizer. So now this is how the transmitter works. Now what happens at the receiver? At the receiver there are only 2 stages. One is decoding, means you convert those bits back to quantized levels, and then you have reconstruction filter, where those discrete time is again converted into continuous time signals. So you have your bits coming in from here, and from there you will have these bits will be converted into your quantized signals by this decoder. This decoder will convert it into this quantized signal, and when you feed this into reconstruction filter, you will have back your signal. So this is how it works for decoders, for receivers. Circuit diagram or working block diagram, you may refer to a book. But in principle, now one more thing has to be discussed, and that is your PCM channel, and your PCM channel has regenerative repeaters. Continuous regenerative repeaters after a gap of certain distance. Why? Because when the PCM channel travel, when the PCM bits travel, these bits are added with AWGN or the thermal or additive white Gaussian noise. So what happens is that they get mixed up with your noise, and this becomes noisy, and after a certain level it becomes very difficult to recognize which is 0 and which is 1. So what happens is that when a noisy signal comes into your receiver, regenerative receiver, it decodes it and again reproduces the signal in its clear or pure form. So again it gets dirty or noisy, you can say, and again you have a clear PCM. So in this way finally at the receiver the noise is countered, the noise of the channel is countered, so you can send your data as long as possible after putting regenerative repeater at equal intervals. All right. So that was all. This was a brief discussion, so we did not discuss everything thoroughly. So thank you for your time and all the best. And the last thing I want to discuss is that if you are not done yet with when you have exams, and if you are not done with your subjects or revision and you still have a lot to do not worry, because a survey suggests that our brain works 350% more efficiently during the exam, and that is why you will understand faster and you will memorize faster now. So all the best.